Hello everyone, welcome to my YouTube channel. So today I am going to share my Nbhm interview experience of 2023 with all of you. I I have just completed my BSc from Presidency University Kolkata. So that's why I applied for both Masters Scholarship Program as well as Doctoral Scholarship Program. Uh, since my score was above the cutoff for PhD program, I got selected for the interviews for both master scholarship program as well as doctoral scholarship program. But it is written that if any student got selected for both interview program, then only one interview will be taken. Okay, so that's why there was exactly one interview session for me, and it was on 2nd June 2023. So first, I can remember that there were 8 professors in my panel, and it was in the afternoon session. Out of 8 professors, only 5 professors asked me questions. Okay, so first, Professor Keshavan, IMSc retired professor. You can see his NPTEL lecture videos of functional analysis that is available in YouTube also. So he first welcomed me and asked me to introduce myself. I introduced myself, and then he asked me that you were a BSc final year student. You have just completed your BSc. So why are you applying for doctoral scholarship program? So I just tell that no sir, there was no separate reason. I just apply for it for experience. Then he told that okay, it is okay. So let's start our interview session. So first, one professor, first, sorry, first Professor Keshavan asked me my favorite topic. So I told that I mainly like abstract algebra. So then one professor asked me which topics have you read yet in abstract algebra. I told that I have read group theory, ring theory, and basic field theory, mainly field extension. Then sir told me, okay, so let's start with ring theory. So my first question was, if f be a field, then what can you say about the polynomial ring fx? So I told that if f be a field, then fx is a PID, that is principal ideal domain. Then he asked me what is the definition of a principal ideal domain. I told the definition. Then he asked me what about its converse. If fx is PID, then what can you say about f? First I think, and then I told that f f is a field. Then he asked me to prove it, and when I start my proof, uh, when I proceed, he repeatedly stopped me and asked me the why this is true, why this is true. I mean, they asked me lots of related questions, like to prove this I use that mm, the concept of prime element, irreducible element. Then he asked me what is its definition. Then I tell that in PID every prime element is every irreducible element is prime. I mean, if and only if any prime element is irreducible, it is if and only if condition in PID. So I mean, whatever result I used to prove this, I mean this question to F be a field, he asked me the reason. I mean, in each and every step, he asked me why this is true, why this is true, and related example and related questions. Okay, so for this part, I mean for ring theory part, I just want to tell that though it was just one or two questions, but there was lots of related questions. Okay, so my suggestion is that whenever, I mean in every interview, if if you are using some theorem to prove, I mean your question, what is asked to you. So if you are going to use some theorem, then definitely you have to know its proof. So otherwise, they will not consider it as a valid proof. Okay. So even if you are going to use any result, then you have to prove it. Okay. So finally, I proved the result, and then he asked me the uh, what are the prime element in Qx? I mean, set of a rational number, polynomial in Qx. What are its prime element? I told that since Qx is PID, I mean Q is field, so Qx is PID, so every prime element is basically irreducible. So the irreducible polynomial. Then he told me, okay, it's okay. Then he asked me a question from group theory that if G be a group of order p square, where p is a prime, having exactly one non-trivial proper subgroup, then what can you say about G? So I told that G is cyclic group of order p square. Then he told me to prove it. So I first proved that I just tell that if G has a element of order p square, then definitely G is cyclic. So we have nothing to prove. If G has no element of order p square, that means every non-identity element of G must have order p. Since p square has only three divisors, and we know that order of an element of a group must divide order of the group. So any element must have order 1, p or p square. Since identity element only can have order 1 and there is no element of order p square, so every non-trivial element has order p. So consider a element A which has no order p and take H be a cyclic subgroup generated by A. And then H must have order p. Now pick any element B from G minus H. Okay, G minus H means G set difference H. I mean, take any element B which is not inside the subgroup H. Then if we can consider the subgroup generated by B, then it is also has order P and it is a different subgroup from H. So we have already got two non-trivial proper subgroup of G. That's a contradiction to our given condition. Hence, G must have at least one element of order p square. Hence, G is a cyclic group of order p square. Then he told that yes, it is correct. Very good. Then he asked me again from ring theory. Uh, asked me that do you know the definition of a nilpotent element in a ring R? I told yes, sir, I know. If for an element x in R there exists a natural number n such that x to the power n equals to 0, which is additive identity of the ring R, then we say that x is nilpotent. Then he told that yes, it is correct. So what are the nilpotent elements of the polynomial ring Rx? I just think for some time and then I told that any polynomial of Rx is a nilpotent element if the coefficients are nilpotent element of the ring R. Then he asked me to prove it. So I just it takes some time because it is a calculative proof. So I take an arbitrary polynomial fx which is equal to summation ai x to the I equal to 0 to n. Then I take if uh, index of nilpotency is n, then fx to the n equal to 0. Then I compare the coefficient and it takes some time. It is not so easy to direct proof. So it takes some time. Then I finally conclude that it is all the coefficient must be nilpotent. Then he told that yes, it is correct. Very good. Then he asked me the what are the units of the polynomial ring Rx. Then I told that if the constant term is unique and all the other terms all the if the constant term is unique and all the other coefficient are nilpotent. Then he again asked me to prove it. Then I again repeatedly say fx be an unit in Rx, and if Gx is its inverse, then fx dot gx, I assume that gx to be another polynomial, and then fx dot gx equal to 1, then I compare the coefficient and finally conclude this. It takes some time to prove it also. Okay. Then he asked me the what are the units of power series ring. No, they first asked me the do you know the definition of a power series ring. So I told that yes, this is the definition of a power series ring. Then they told me that what are the units of a power series ring are x. So so then I start thinking, and finally I just tell that if the I mean if the constant term, I mean the first term, series ring is basically a series an x to the n equal to 0 to infinity. So I tell that if a0 is unit, mm, if a0 is unique and all the other terms are nilpotent by similar, I just tell it by using the similar concept of the previous case. And then he asked me, okay, you tell the similar thing with the previous thing, but are you sure that these are the units element? Because this is not not at all a polynomial. It is an infinite sum. So you cannot do a fixed degree, then you just compare the coefficient. It is not like that. So are you sure that these are the unit? Then I start thinking, and I told that yes sir, I think so. I just try to give some idea, but I finally was not able to complete my proof. I just try to give some idea. Then he told me, yes, I believe you can do it. So it's okay. Uh, then he asked me, okay, your abstract algebra part is over. Now we can start linear algebra. Then one ma'am from ISI Delhi, I think the name was Nbhm, who asked me the question from linear algebra. I don't recall the name of the professor who asked me these questions from abstract algebra, but I recall the name of the professors, I mean the madam who asked me the questions from linear algebra. So first asked me, what have you read in linear algebra? I told that I have read uh, basic things of linear algebra like vector space, linear transformations, properties of matrix, everything, and then I also read diagonalization, inner product space, and so on. Then asked me, okay, tell me the definition of a diagonalizable matrix. I told, and in that case, I told that that A is basically P inverse dP, where P is an invertible matrix and D is the diagonal matrix. Okay. Then she asked me that are P and D unique? I told no ma'am, it is not necessarily unique because say I have a diagonal matrix D where D is basically the diagonal entry is basically lambda 1 lambda 2 up to lambda n. If the if the matrix has order n cross n, I can change the diagonal entries, like say I start with lambda n, then lambda n minus 1, and so on, then lambda 1, and whatever I like. Then ma'am told me that yes, it is correct, but if we allow the permutation, then is it unique? I told yes ma'am, then it is unique, because since for any matrix A, eigenvalues are always same, eigenvalues are always fixed, so the diagonal matrix are same up to permutation. Then she told me yes, it is correct. Now what about the invertible matrix P? Mhm. I told that for P it is also possible to make a permutation on the eigenvectors, because P is basically made by eigenvectors. Write down it's as a column of the matrix P. Uh, then ma'am told me yes, it is correct. Then what about the other case? I mean, if we allow the permutation and if we allow the scalar multiplication with the eigenvector, then will it be unique? I mean, for other case, will it be unique? So then I told that uh, it may or it may not. Then ma'am asked me, okay, if the matrix is diagonalizable and if all the eigenvalues are distinct, then is it unique matrix P? I told yes ma'am, in that case it is unique because since all the eigenvalues are distinct, so all the eigenvalues have same geometry. I mean, all the eigenvalues have geometric multiplicity 1. So eigenvectors are eigenspace is basically one dimensional. So it must we have to choose same eigenvector for each case. So, or it is just because scalar multiplication is allowed. So we can take either the scalar multiplication or this. So it is unique. Ma'am told yes, it is correct. Very good. Tell me what about the other case? I mean, if the eigenvalues are not necessarily distinct, then in that case it is possible to be two distinct matrix uh, P and Q such that A is basically P inverse dP and Q inverse dQ. Then I told yes ma'am, it is possible because if the geometric multiplicity is not necessarily 1 say 2, then eigenspace is two dimensional, so we can choose we can choose two different eigenvector according to our choice. So in that case P and Q will be distinct. Then ma'am told me yes, it is correct. Then she asked me some related question. Okay, uh, for these two topic question, and that questions are easy. Then she asked me that if A is a 4 cross 4 diagonalizable matrix which has exactly two non-zero eigenvalues, then what can you say about rank of A? I told rank of A is 2 since it has exactly two zero eigenvalues. So algebraic multiplicity of 0 is 2. So since it is diagonalizable, so geometric multiplicity of 0 is also 2. So definitely rank of the matrix A is 2. Then she asked me that what about non-diagonalizable matrix? I told them that ma'am, for non-diagonalizable matrix rank is greater equal to 2. Rank is greater equal to 2 because since it is non-diagonalizable and geometric multiplicity is always less equal to algebraic multiplicity. So algebraic multiplicity is 2 given. So geometric multiplicity is less than equal to 2. So nullity is less equal to 2. Geometric multiplicity for 0 is less equal to 2. So nullity is less equal to 2. So rank is greater equal to 2. Then she asked me to give an example for which case rank is 2 but not diagonalizable. Okay. I gave an example. Then it was done for linear algebra. So for both abstract algebra part and for linear algebra part, I solved almost all the questions correctly, and they seems to be happy after taking my interview for these two part. Then and okay, I forgot. Then Professor Keshavan again asked me a question that let A and B two real matrix n cross n such that they are similar over C. Okay, field C. Then will they be similar over R? So I just start thinking and it takes some time. Then he gave some hint and finally I almost complete the proof. It is a lengthy proof. Then he told me okay, it is you gave an idea, it is okay, so no problem. Then he asked me, then one professor asked me from real analysis part. So he asked me that if f from first he asked me to give the definition of continuity. I gave the definition. Then he asked me that if from R to R be a continuous map that is strictly monotone, will it be open map? No, no, sorry, forget. Then he asked me that do you know the definition of open map? I told that yes, sir. If it maps open set to open set, then he told yes, it is correct. And then it told me that if f from R to R is a continuous map that is strictly monotone, then will it be open? First I start thinking, then I told that yes sir, it will be open. Then he asked me to prove it. I told that since any open set of R can be written as union of open intervals, so it is enough to uh, check the image of open intervals under F. So without loss of generality, I assume that F is strictly increasing. So I told that if I have open interval AB, it will map to open interval FA comma FB. So that is also a open set. Since any open set can be written as union of open intervals, so it will map every open set to open sets. So he told me yes, it is correct. Then he asked me the converse, but if F is a continuous open map, I mean if from R to R is continuous map and also it is open, then will it be strictly monotone? Then I start thinking sometime and start to try to draw some picture, and then I finally conclude yes that it will be open. Then he asked me to prove it. Then I just take say let if possible it is not monotone. Then I have three distinct point A, B, C such that f of A less than f of B greater than f of C. Then there must be some maxima. I just use some concept of maxima minima in between the interval AC, and I finally conclude that it will not map the open set to the open set. Okay, so then he told that yes, it is correct. Uh, then one professor from KOSM, the name was Professor Pranav Horidas. He also gave NPTEL lectures. I think complex analysis lectures was also available in YouTube. So he he asked me, okay, Swapnajit, you, you have already given interview for abstract algebra, linear algebra, also real analysis. So I just want to ask you two questions from number theory because almost 1 hour done, uh, almost 1 hour done. So and you are so tired, we can understand. So I just ask you two simple questions, and since I was not so much comfortable in number theory, so I was afraid of this. But he asked me first question that if A is a set, okay, where n is a fixed natural number, A is a set 1, 2, 3, 4 up to 2n. If you pick any n plus 1 elements out of this set A from this set A, then there exist A and B such that GCD of AB equal to 1. Try to prove it. So I start thinking it was an easy problem, but I start thinking. Then I told that yes, sir, it is. No, sorry. I just start thinking, and uh, I actually so much overthink for this question. I try to use the Euler phi function and many things it is, but I did not think it in a simple way. Then he told me think about two consecutive numbers. Then I think that okay, if I choose any n plus 1 elements, then at least two elements are consecutive, and we know that any two consecutive numbers are co-prime. So GCD of AB equal to 1. Then he told yes, it is correct. Very good. Now he asked me a question that let A is a set for uh, 1 to up to 2n. P if you pick any n plus 1 elements, then there exist two elements A and B such that A divides B. So I start thinking for this question, but finally this was the only question which I cannot be able to give answer. And then he told me, I mean the professor Ponogodidas told me, don't be worried, you already gave lots of answers. So it is this problem is for your today's dinner. You should think this problem in your dinner time. Okay, then it was done. Then Professor Keshavan told me your interview is over, and my interview was almost 1 hour 25 minutes, 20 to 25 minutes, what I can recall. So total five professors asked me the question. So this was the entire questions and entire interview session. So I mean, I gave lots of interviews like TFR Mumbai interview, TFR CAM interview, CMI interview, but but I think this was the I mean this was the longest interview I gave, and it was so much. I mean, it takes lots of time, from 1 hour 25 minutes, and it was in online mode. So it was quite difficult to for me. But I gave answers very well. So I think that I should be selected for at least master's program. But I don't know whether I will be selected for doctoral program or not. But when result comes, I see that I got selected for both master's program as well as doctoral program. So I was so much happy. So so that's the entire story of my interview. So I think this will help you a lot to understand that what kind of questions are basically asked in uh, NBHM level interview. So and also in other interviews. So my main suggestion is that for interview, try to use try to use basic result which are well known result. Don't try to use some advanced result, because if you try to use that result, then definitely they will ask you to prove that, and if you cannot prove, then it is definitely, it is a very bad impact. Okay, it creates a lot bad impact of your info on your interview. So I just want to suggest that please try to answer from a basic level. Don't try to use so much advanced concept, uh, because if you know the proof of the theorem, then you can easily use that, no problem. But if you don't know, don't try to use that theorem. If you have no option left, then you should mm, uh, use that theorem. Okay, so that's the whole thing. And if you don't know any answer, it is not a big issue, because they will continuously give you hint, and they will see that whether using their hint you are able to prove or not. Okay, even if you don't know some answer, it is not a big issue. It will not create any bad effect, but they will see that whether you are able to use their hints or not. Okay, so the entire that's the entire story. So thank you, keep watching.